Hi, this is Pranav Kurzekar. Today I'll demonstrate the DFMPro solution for Creo platform. DFMPro solution is tightly integrated into different CAD platforms, catering to different manufacturing processes such as injection molding, casting, assembly, additive manufacturing, sheet metal, and so on. A DFMPro solution can be used by a designer to validate the features that he has created on the design from a manufacturing point of view. For today's demonstration, I will be using a sheet metal part which is still in its intermediate stage of design process. However, I would like to quickly validate whether some of the features that I have created on this part do match the standards which are provided in the guidelines. So to begin the validation, I click on DFMPro inside the Creo framework and say Start DFMPro. I have to provide a couple of inputs such as the rule file which is pre-configured with the standards, along with the design for, that is the manufacturing process by which this part will be manufactured. I select sheet metal and I click on run. I additionally provide a couple of inputs which help me to begin the validation. As soon as the validation is finished, I get the results on the right hand side of the DFMPro window, wherein it says that two rules have failed for this particular part. First one is the counterbore hole distance to part edge, which essentially highlights to the designer that the distance between the counterbore hole and the edge of the part should be sufficient enough so as to avoid any cracking or deformation during manufacturing. So the distance to thickness ratio is something that needs to be matched with the guidelines or standards set in the rule file. Similarly, instance number 2 is talking about the second counterbore hole and the distance to thickness ratio is 1.25. Now, since I am already inside the Creo framework, I navigate to the model tree and make the relevant changes to the parameters associated with these counterbore holes. Now, apart from counterbore hole distance to part edge, there is another rule which has failed, which is called as interference in flat pattern. Now, this rule essentially tries to give a message that during the unfolded state of a sheet metal part, there shouldn't be any interference caused due to the features which are present on the sheet metal component. So in this particular case, it is highlighting me these couple of flanges which will cause an interference during manufacturing. So I make the relevant changes to these flanges and ensure that they match the standards set in the rule file. Now, to ensure that my changes are taken into consideration by DFMPro during my next rerun, I save this component, and as soon as I save, the validation area turns yellow, which tells me that I need to rerun the analysis. So I click on run, I provide the necessary inputs and the validation begins. So as can be seen, the rules which were categorized earlier as failed have now moved to rules passed, which means that I have made the necessary changes to my design as per the DFMPro guidelines. I have successfully validated the component using DFMPro. For more such demonstration videos, please visit www.dfmpro.com, or if you'd like to have more information on DFMPro, please write in to us at dfmpro.marketing@geometryglobal.com.